All right, so here's the setup. This is MSI Z77AGD80 on the right there. That's a Z77 chipset paired with an Intel Core i7-3770K, codename Ivy Bridge. Along with that, we have an NVIDIA Kepler GPU. This is a GeForce GTX 680. That's the big card there sticking out of the PCIe by 16 slot. This whole motherboard has a single cable coming out of it. That's a Thunderbolt cable. So for those of you who aren't familiar with Thunderbolt, it is an interface that can deliver both PCI Express and DisplayPort point to point. So any PCIe devices that exist, whether they are SATA controllers, Ethernet controllers, FireWire controllers, whatever, if it's a PCIe device, that can exist at the other end of this cable. And to the motherboard, to the system, it'll look like those devices are local. And that's exactly what the demo is that we have set up here today. So we have this motherboard, which is the first non-Apple Thunderbolt-enabled product we've tested. We've got that single cable connecting directly to Apple's Thunderbolt display, so interoperability with existing Thunderbolt devices is there. So this is a Thunderbolt display. This display itself has a built-in gigabit Ethernet controller, a FireWire 800 controller, USB hub, a bunch of other stuff. Those all appear to, at least the GigE controller and the FireWire 800 controller, appear to the Z77 platform. Again, those are PCIe devices and they're carried over the Thunderbolt cable. Now, that Thunderbolt display has another Thunderbolt port on it, and connected to that is the LaCie 2Big. That's that big aluminum chassis there on the left. And that chassis has two 3.5-inch hard drives. There's also another Thunderbolt port on it, which connects to the next LaCie drive, which is the LaCie Little Big Disk. That's the SSD version with two Intel SSD 320s. And then finally, that also has another Thunderbolt port on it, which connects to the Elgato Thunderbolt SSD. And there's a single SandForce SF1200 SanDisk-based SSD in there. Now, all three of those very different storage arrays, we're reading from them at a rate of just under 7 gigabits per second. So that's actually faster than USB 3 line speed at this point. Now, in addition to the 7 gigabits that we're reading from those three, if you look at this panel, we're sending video out to this panel. This is a 2560 by 1440 panel at 32 bits per color at a 60 hertz refresh rate. That's also another 7 gigabits of data just to display the screen that you're seeing. So it's an aggregate of 14 gigabits out of an available 20 gigabits over this single Thunderbolt link. And that's just a ton of bandwidth. It's an unheard amount of bandwidth that we've been able to send over effectively a $50 cable. Non-optical at this point. This is still over copper. And this is it, right? Like, this is what we've only been able to do on Macs for the past year, but this year it changes. So this MSI board is going to be one of the first available with Thunderbolt support. It should be available in the next month. You don't actually need any special drivers for this to work. It just works out of the box, because again, it's to the PC, it just appears as a bunch of PCIe devices. And if you look at the iometer test on the right shows us, the bandwidth that we're getting to the storage devices. The reason I have the Virtu window up there on the left is to show you that Virtu is still supported here. So you can actually, if you fire up a 3D game, that'll be driven by the GTX 680. Frame buffer gets copied to the integrated graphics frame buffer, and video is displayed over Thunderbolt still. So you actually make no sacrifices there. This works just like any other integrated graphics solution. It's just that you're driving both video and data over this Thunderbolt connection. Now, admittedly, Thunderbolt is very, very useful on the mobile side, but I can see some usage models in the desktop space as well. There's still some rough edges, just like we've seen under OS X. This isn't as plug and play as USB would, particularly under Windows. There are limitations such as any device that you want to appear that happens to be Thunderbolt connected, any of those devices have to be present at boot. So you can't just plug and play a Thunderbolt storage device under Windows like you can under OS X. But similarities with the quirkiness, I've seen issues with you having to power cycle certain Thunderbolt devices, similar to what we see under OS X. Things seem a little more finicky under Windows right now. My guess is that this is still a brand new platform, and a lot of these devices have really only been tested and validated and were developed on Macs. I expect all of that to change over time. So, over the course of this year, especially as we get more Thunderbolt-enabled motherboards out in the market, more Thunderbolt-enabled PC notebooks, we'll also see a wider spread of compatibility testing and hopefully cheaper devices going forward as well. So there you have it. This is what we've been waiting for, and it's here. Now the trick is to get it ubiquitous and to drive costs down. Both are things that I'm expecting to happen over the course of the next couple of years here.